Good morning, everyone. Thank you very much for joining the 101 stream. And the topic of this session is Db2 versus IMS, and it's presented by Marcus David. Before I hand over to Marcus, just a few things. If you have any questions, there's a chat, so please just put your questions into the chat. We are recording the session, so you have access to the recording afterwards, and we would love to hear your feedback. So you can either scan the QR code, which is here on that slide, or you can just use that session ID to give your feedback. With that, I hand over to you, Marcus.
Great. Thank you very much, Lena. Okay, so I was giving this presentation yesterday because Harvey Singh was supposed to have delivered this. So this is his presentation, so I'm not taking any credit at all. I've added a few slides myself towards the end. Harvey was unable to present this morning due to a family bereavement, so I stepped in. So let me take you through Harvey's presentation. So this was Harvey's introduction slide. So Harvey's got a Bachelor of Engineering from Electronic Engineering at Birmingham. He works for RSM Partners, which is now a BMC company, and he helps out with the MIT, the Mainframer in Training program, and he's been doing 2.5 years of client support, working with different client partners as part of BMC Managed Services. A little bit about myself. I've got BSc in Computer Science from Aberystwyth University, a member of the British Computer Society, chartered professional, blah, blah, blah. 30 years in IT, started off as a programmer, systems programmer, database administrator, and a little bit of work as a database consultant, and I'm now a lead product developer for BMC software. And I also co-chair the Db2 stream for GSE. So after 30 years in IT, you'd have thought I'd be able to wing this. But presentation is always a presentation, isn't it? So what does a DBA do? What does Harvey do? Because this is his job. He provides standards for and the administration of databases and their use for his clients. He guides and reviews and approves the design of new databases and determines the rules of access to the data and its monitoring and security, so it keeps his eye on them. He ensures the database availability and integrity and monitors the activities that are necessary for reorganization, backup and recovery. And he approves the operation of new programs within the existing production databases based on testing with test data. So a couple of disclaimers to begin with. This session is aimed at those completely new to database management systems. It's not a recommendation of either product, IMS or Db2. Many shops of them both working in tandem. We, BMC and RSM Partners, do not have any affiliation with IBM, though we are business partners. And I encourage you to look at the IBM Knowledge Center and IBM Red Books for more information if you're interested. So we are focusing on Db2 for ZOS only. So you've got to stick to what you know. A bit of housekeeping. I'll have questions at the end. You can raise your hand in the chat. Depending on Lena to keep her eye on the chat as I'm going through. But if you're interested in anything, then please reach out via email, LinkedIn, Twitter, Instagram. My details were on the file earlier. The presentation will be available later, so you can compare each product section by section, and please don't forget to leave feedback. So, as I mentioned earlier, a database is a collection of related data organized in a way that can be processed by application programs. A database management system consists of a set of licensed programs that define and maintain the structure of the database and keep its integrity. Database applications include healthcare, finance, utilities, aerospace, government, retail, manufacturing. So firstly, let's have a look at IMS. What is IMS? IBM's information management system. It's a hierarchical database and information management system with extensive transaction processing capabilities. It was designed started off in 1966, designed by IBM with the help of Rockwell and Caterpillar for the Apollo space program, where it was used to maintain the inventory of a very large bill of materials for the Saturn V moon rocket and Apollo space vehicle. IMS only runs on ZOS, depending on which side of the Atlantic you live. It manages over 15 million gigabytes of production data across the planet. Over 95% of Fortune 100, I think that's supposed to be, companies use IMS. It manages over 50, yeah, he's got that twice. Oops, should have picked that out. $2.5 trillion a day is transferred through IMS by one customer alone. I wonder who that is. Probably Donald Trump. IMS processes over 50 billion transactions a day across the world. And in 2013, IBM benchmarked 100,000 IMS transactions per second. A single IMS system has processed over 6,000 transactions per second over a TCP/IP connection, so it's used quite extensively. IMS database is a group of related database records, and I shall explain what that looks like in a minute. A database record is a single hierarchy of related segments, and a segment is a group of related fields, and a field is a single piece of data. So it can be used to order segments, it can be used as a qualifier for searching, and an IMS database will always look like hierarchies, which is like an upside down tree. The structure of an IMS subsystem, you have a data controller region and a database region. IMS provides its own logging, restart, recovery. It handles message queues. You can log on to an IMS region from a terminal. And it provides an interface to the network for transaction management functions. It also provides interface to ZOS system for operation of IMS systems. It controls and schedules and dispatches application programs. It provides access for non-SNA networks, and it also provides ODBA interface for Db2. So this is what a hierarchical database is. Now, believe it or not, after 30 years in IT, most of which have been with Db2, I have hardly ever, by hardly ever, read never, touched an IMS system. So what is a hierarchical database? An IMS database consists of a series of database records, and a database record consists of a series of segments. A segment, if I can go around that, a segment is the smallest amount of data that can be stored in IMS. The segments are stored in a hierarchical structure. Right, there we go. that includes these basic elements. The root, this is the top of the structure, and there is only one root segment per database record. Here we have the dependent segments. Segments that depend on other segments are called dependent segments. All other segments other than the root segment in the database record are dependent. So in this hierarchy, we have parents and children. So that's a parent, and these are children. The root segment, by definition, doesn't have any parents. But a root can have one or more child segments. And inside each segment is a field. And the fields contain the data that live in the database. So let's see what an example of a hierarchical structure looks like. So this is an organizational chart. So if you have a business with lots of employees, this is how an IMS database may be structured. The root segment here would be a business unit. So this would have an ID of 1. Under the root segment are 2 child segments, department and employee. The department segment includes instances for departments A, B, and C. The employee segment includes 3 instances for employees Jenny, Jane, and Jose. Applications, like business applications, they traverse these hierarchies to get information they need to complete tasks like updating a bank account or changing a health record. If an IMS database uses a secondary index, it helps you get to the correct segment without needing to traverse the entire hierarchy. A secondary index provides a different route to a specific segment by using a root or dependent segment as the entry location for that application. The key concept to remember is that each segment in IMS database is either related to or dependent on an item that's above or below it in the hierarchy. To make access in segments more efficient and faster for different applications, you can define logical relationships or views between independent segments. Think of a logical view as a different way to see just the segments that the application needs, rather than the physical way the segments are stored in the database. IMS has something called Common System Services. You can run commands, you can stop or start the database, you can run utility programs, or you can run user-written exit routines. You can define the services you want within the definition process. There are different organization methods as well within IMS. Hierarchical direct access method, hierarchical indexed direct access method, index sequential access method, and generalized sequential access method. And each of these can be partitioned for greater data growth. You've also got something called a data entry database, or fast path, which is incredibly fast. Accessing DL1, accessing IMS databases uses something called DL1. It's a standard interface, or data language 1. It's a standard interface to IMS functions. So this is how you call your database and get your data out using a call to DL1. It's not the easiest way of getting at your data, but it certainly is quite fast. So your application program, generally COBOL, PL1, or assembler. You define your PCB areas. A PCB is a method of accessing, of defining how you're going to access your data in DL1. You then call DL1, the database functions, to retrieve, insert, replace, or delete a record. Check the status codes, do what you need to do with the data, and then terminate. So that was a whistle-stop tour of DL1. So now let's introduce DB2. DB2 is a relational database management system introduced by IBM in 1983. It's short for Database2, and recently the capital B was changed to a small b. It fully supports relational database model theory. It supports SQL. It runs on Linux, Unix, Windows, ZOS, VMBSE, and for those of you old enough to remember, OS2 and iSeries. 66 of the top 66 banks in the world use DB2 for ZOS. All of the global Fortune 100 banking and financial services use it. 21 of the world's top 25 insurance companies use it. 90% of all global credit card transactions are processed on IBM Z. The world's largest credit card provider has experienced zero downtime in over 20 years. The world's largest banking benchmark result was 9,445 transactions per second. The world's largest bank has got 620 million accounts with 120 million online users. Another North American bank had zero unplanned downtime in over 11 years. Most of the top US retailers use it. 71% of global Fortune 500 run their businesses on mainframe. DB2 for ZOS can handle 10 million inserts per second. It can hold 280 trillion rows in a single table with agile partition technology. DB2 is now a fully qualified in-memory database, providing 23% CPU reduction for lookups with advanced in-memory techniques. 360 million transactions per hour are handled by DB2 through RESTful web APIs. And you can deliver analytical insights faster with 2 times speed up for query workloads and 100 times speed up for targeted queries. So a relational database is a database in which all the data is logically contained in tables. And in a relational database, referential integrity ensures data integrity by enforcing rules with referential constraints, check constraints, and triggers. You can rely on these to ensure the integrity and validity of the data rather than having to depend on individual applications to do the work. So what does DB2 look like? It contains databases, storage groups, table spaces, tables, indexes, and views. A database is a set of DB2 structures that include tables. The tables sit in table spaces, which are basically files which contain physical files which contain the logical data. The table spaces are held on volumes and disks which are defined in a storage group. Your data is held in these tables as rows and columns, and you can have indexes on these columns in order to provide faster access to your data and to maintain integrity. And like IMS, you can have views, which is an alternate way of representing data that can spread across one or more tables. DB2, as a DBMS, has a neat way of separating the physical data model with the logical data model. So your physical data model, which is here, is made up of a database which contains which can contain one or more table spaces and one or more index space per table space. Now, when you're handling hundreds of trillions of rows of data, you will probably need a lot of disks. And these disks are contained or defined to a storage group, and your table space can be split across many partitions across different storage groups, across different disks. And the database management system maintains integrity between all of these different objects. Now, inside your table, which can be spread across many many partitions of a table space across many disks, Db2 maintains your data. Your data is held in columns and rows, a bit like a spreadsheet. So, for example, you have a data department table, which contains department information, a primary key, which defines each individual row, and the data pertaining to that row. You can have another table, for example, the employee table, which contains a primary key to identify uniquely each row, and a foreign key related to this department table here, which tells you what department a particular employee belongs in. Two common interfaces to Db2 are Spoofy, SQL processor using file input, which is an online method of accessing Db2 data and controlling and managing the database, or QMF, which is a query management facility, which is a powerful tool that performs queries and reporting for Db2. Accessing your data is quite easy through the ANSI standard SQL. Db2 isn't quite ANSI standard, it's mostly, it has its own foibles, and it does take time to catch up with ANSI standards, but it's pretty similar. So you can create your table, and you can insert rows into your table. You can select data from your table. You can delete it. You can update it. You can merge it, which is a cross between an insert and an update. You can have views across different tables, so you can join tables together. You can define user-defined data types if you have a strongly typed programming language to access your data with. You can define user-defined functions. So this is programmatically encapsulating business functions within Db2. You can have triggers. For example, if you wanted to insert a row into a log table every time somebody updated the department table, then you could set a trigger to insert something into a different table or delete something from a different table if something is deleted or inserted or updated somewhere else. Db2 can contain large objects, for example, audio files, video files, huge character files like Word documents or something, or even binary, such as encrypted data. And it now fully supports XML, and you can perform XML lookups within Db2 quite natively. The Db2 Catalog is the metadata database. So this is the database about Db2 and all of the other user databases inside it. So there's a table which contains a list of all of the databases that are defined to Db2. There's a table which contains a list of all of the packages or programs that access your data. As you can see here, there are dozens and dozens of tables within the catalog. So how do you get at your data? obviously, you write programs to get at your data. And these can be in assembler, PL1, COBOL, C, C++, Rex, which is the ZOS scripting language, Java, SQL procedural language, or Python nowadays. Like user-defined functions, you can write stored procedures, which are business logic programs contained and running inside the database itself. So, excuse me. So if you had a program running on your phone, you didn't want to have to transfer data left, right, and center between your phone and the network and the mainframe to get at DB2. Your application would then call a stored procedure, which would then do all the processing on the data server on DB2 itself and bring the results back to your phone. It's fully ODBC compliant, so you can run your programs to access your data off the mainframe, such as Java, Excel, or Python. And we now have full RESTful services, so you can call APIs to run your programs to get at your data. So who uses DB2? Obviously, apart from your programmers and your end users, you have a team of people who look after it. You've got the systems programmer and the administrator. These are the guys and girls who will install, maintain and tune DB2. They modify the subsystem parameters. They identify and sort out problems. And they are the ones that interface between the IBM support and your operations support. You've got a database administrator. Now, these guys, they design your database, they perform data modeling, they are the ones that issue site standards. These are the ones who create, drop, and alter your Db2 objects. They analyze performance and tune SQL queries. They're the ones that look after the housekeeping of the database to make sure that the backups and recoveries are running to order. And you've also got a security administrator. These are the ones who decide who is allowed to do what. These are the ones who issue the grant and revoke commands for the authority of running DB2 commands. So, what are the pros and cons for IMS and DB2? IMS is relatively static. Data requests or segment search arguments, they may be very complex to construct, but once they are written, they are very efficient. It's navigational, so you need to know the structure to get to the right data. You need to know what your database looks like before you can get at it. So the logical data model is tied to the physical data model. DB2 is relational, it's non-hierarchical. It's used for data searches that may run only once or a few times and then change. It's easy to code requests for data from practically anywhere using a standard query language, SQL. You can change the database structure while people are using it. There's no impact on the existing application. It's non-navigational, so there's no need to know the structure to get to the right data. All you need to know is your schema name, your table name, and the column names that contain the data that you want, and the predicates to get at the individual rows that you're interested in. So DB2 separates the logical data model from the physical data model. That is DB2 and IMS 101. If you've enjoyed or understood this presentation, my name is Marcus Davidge. If you haven't, it's Harvey Singh. So please submit your session feedback. The session is 2AV. There's a little QR code. and please consider donating to NHS Charities Together.
Thank you very much, Marcus. I'm just looking at the chat, and there is a question on set. So the question is, ISPF guides you to all the features of DB2. Is there a similar set of ISPF menus to access IMS?
No, not that I'm aware of. Most accesses to IMS are done via batch. You can log on to an IMS data control region once you've written applications and put your applications in the region, but there isn't anything that easy to get at IMS, as far as I'm aware. Maybe someone longer in the tooth than I might be able to answer that one.
Okay, thank you very much, Marcus. I'm not seeing any other questions in the chat right now. So I will go ahead and close the session. Thanks again, everyone who attended.
Thank you very much, everyone.
All right, enjoy the rest of your days. Bye.